So question 9 reads, let's read through the question. In the diagram below, not drawn to scale, meaning that the lengths are not actually the lengths that are given. DEF is a triangle with DE being equal to 15 centimeters. DF is equal to 10 centimeters. And angle DEF is equal to 40 degrees. DX is perpendicular to EF. That means that the line DX meets the line EF at 90 degrees, which is illustrated by the small box at the bottom. Calculate the length in centimeters of DX. So you want to find this length here from D to X, which is the length I want to draw in red. So you want to find for that length there, DX. Now, when it is given these questions, and you analyze the questions, if you want, you can isolate the triangle so you can be able to see what they're asking you better. So when isolating these triangles, we have the triangle here on the right hand side. All right, so that is this triangle here. To the top is D, we have X, and we have E. Right, those are the points. Here is 15 cm, right angle triangle, and here is 40 degrees. You want to find out for the length DX. Right, so that is this length here. DX is what you want to find out for. When it is you want to find for an unknown side, write out the information that is given. You know what the angle is. The angle is 40. If you draw an arrow from the angle, the arrow points towards the opposite side. So the arrow now points towards the opposite side. So we can call that side the opposite side. The longest side of the triangle is called the hypotenuse. All right, so we have the hypotenuse. So the side that is given is the hypotenuse, and the side that is not given that you want to find for is the opposite. So using the unknown side and the known side, we need to use a trigonometric ratio that involves those two sides, which is your unknown side and your known side. The unknown side is the opposite, and the known side is the hypotenuse. So the trigonometric ratio that uses the opposite and the hypotenuse will be sine. All right, so we say sine theta is equal to opposite over hypotenuse. And we substitute the relevant values. So we say here, when substituted, theta is equal to the angle, so theta will be equal to 40. Is equal to the opposite side. Let's say the opposite side in this case is called dx. Right, that is the length you want to find for dx. You can call it whatever you want. You can call it A, B, C, D. Right, but just use the side that we want to find for, and it is labeled dx. So I would use dx. All over the hypotenuse, and the hypotenuse is 15 centimeters. Sine 40 is the same as saying sine 40 over 1. And when it is you have two fraction-like terms on either side of an equal sign, to break this down, you cross multiply. So we say dx multiplied by 1, you get dx. Anything by 1 is itself. It's equal to sine 40 multiplied by 15. When you cross multiply, numerator is multiplied by denominator on either side. So dx multiplied by the denominator on the next side is 1, you get dx. Sine 40 multiplied by the denominator on the next side is 15. So we get sine 40 by 15. Move this out in your calculator and you will get the value of dx. So we get dx is equal to sine 40. So we put sine 40 multiplied by 15. The answer you get 9 point what?
9.6.
9.6 centimeters. Also got dx is equal to 9.6 cm.
Yes, sir. Yes, sir.
Nice. So this is the first part, finding out the length of dx. So part 2 of question 9 reads, you want to find out the angle, the size of the angle EDF. Now EDF, what is EDF? So you're moving from point E, which is this point right here in red, to point D to point F. So you see, the angle made between E and D and F, those two lines, that is the angle you want to find. This whole angle right here. But that angle is the angle of two triangles. And if it is that you were to draw these two triangles, so let me just draw these two triangles here. You have triangle on the right hand side, look like this. And then you have the next triangle. You have the triangle on your left hand side and then the triangle on your right hand side. All right, so this is just a sketch of it. And we want to write in the figures. So if you combine these two triangles here, you get the triangle in question D. You want to find for this angle here and this angle on top here. When combined, will give us EDF. Somebody want to ask something? We have here being 10 cm. And we initially found out what dx was. What was the length of dx in part 1?
9.6.
9.6. And in the next triangle, we have 15 centimeters. And the standing part here, which is dx, is 9.6 here. And you want to find out for the angles of each of the triangle. Now let's call this angle here x, and let's call this one here y. So find for x and angle y. Now the first one, I'll do the first one in blue, so you will be able to see it. You label the sides that you have lengths for. So when you draw an arrow from angle x, that points towards the opposite side. The longest side is the hypotenuse. And the next side between the opposite and the hypotenuse line next to the angle is called the adjacent. So you have the opposite, adjacent, and hypotenuse. You would only use the sides that we have a length for. So we have a length for the adjacent and we have a length for the hypotenuse. And which ratio, which trigonometric ratio uses adjacent and hypotenuse?
Cosine.
Cosine. So we can say here that cosine x is equal to adjacent over hypotenuse. We substitute the value for adjacent. What is the length for the adjacent side? 9.6.
9.6.
And the hypotenuse is how much?
10 centimeters.
10 centimeters. You want x alone. So you see the cosine, you want to eliminate the cosine. So we multiply on both sides by the inverse of cosine. Right? Cosine by its inverse, that means you get rid of the cosine sign. So anytime you multiply something by the inverse, it disappears. So if you multiply both sides by the inverse of cosine, you get x is equal to cosine inverse of 9.6 over 10. So we get x is equal to cosine inverse of 9.6 over 10. They get cosine inverse, put on the calculator, ensure that your calculator is in degrees. If you look on top, you'll see DEG. Press second function, cosine, open brackets, 9.6 divided by 10, close brackets. And what we got? We got x is equal to 16 point what?
2.
6. Or 16, you can round it off, 16.3 degrees. All right, so that's the value we got for x. Now let's find out what y is. Draw an arrow from y. Y, that arrow points towards the opposite side. The longest side of the triangle is called the hypotenuse. And the next side, lying next to the angle, is the adjacent. So we have a length for the adjacent and we have a length for the hypotenuse. Adjacent and hypotenuse gives us the cosine. Because remember, sine is equal to opposite over hypotenuse, tan is opposite over adjacent, and cosine is adjacent over hypotenuse. So you write out here cosine, well, the angle we're using is y, is equal to adjacent divided by hypotenuse. Substitute the relevant values. We get cosine y is equal to the adjacent side is 9.6 divided by the hypotenuse is 15. Same thing we did. Basically, you want to get rid of the cosine. Right? So you could say like the cosine goes across on the next side. Right? You multiply either side by the inverse, or think of it as if the cosine goes across, it becomes inverse, which is written as cosine to the power minus 1 of 9.6 over 15. To get this, you press second function, cosine. 9.6 divided by 15. And when you work this out, how much you got? 50.2?
Yes, sir.
Nice. So we got this angle here being 50.2. And this one here being 16.3. To find out for the total angle, what would the total angle be?
66.5.
Right, so the total angle would be the 50.2. So we put 50.2 plus 16.3. And when you add this, you get 66.5 degrees. So you need to be consistent. If you know you're working to one decimal place, you work to one decimal place and ensure that you round it off correctly. Right, so look at the point after your first decimal place. If it's 5 or more, you add 1. If it's 4 or less, you leave it as it is. Right, so consistency matters. So this is how we work for an angle as well as finding for an unknown side, given an angle on one side of the right angle triangle.